Hi, today we'll be working on lesson 5.7, which is graphing rational functions. Now, I might have done some of this with you in class, so what I'm going to be doing is at least one example fully. If you understand it, just scroll down to where we stopped in class. So let's start with the first example, which is x squared minus 4 over x squared plus 5x plus 6. Now remember what I told you in class is that first of all you have to decide in what form is it given to you. Is it given in standard or in transformed form? So what I'm going to do is I'm going to try to find the space over here and remind you what is a transformed form. Anything in the form of y equals to a over x minus h plus k is going to be the transformed equation. And we've done this in 5.6, so you can go and look at the notes from there. And there's a way to find your vertical asymptote, your horizontal asymptote, and everything else that you need. Like an example would be 1 over x minus 3 plus 2 on the outside. So this is going to be your transformed form. And you graph it in a specific way. Now today we're going to be focusing on standard form. And standard form, as you can see, where you have a fraction. And there could be an x on the top, an x on the bottom, and you might have even an x squared. So if you have a standard form, the first thing that you should do is factor it. So that's going to be your first step always. So the top would factor to be x minus 2 into x plus 2. And the bottom would be x plus 3 into x plus 2. Again, this is going to be your factored form. After you factor the top and the bottom, you move on to the second step, which is to simplify it. So as you can see, there's an x plus 2 on the top, x plus 2 on the bottom. So my simplified form is going to be x minus 2 over x plus 3. Now, you have to, I tried to divide this into a box, and I'm going to give you this box whenever you have a quiz or a test to try to organize your way. Now, you're going to be using the standard form to do the y-intercept, the horizontal asymptote, and the range. You're going to be using the factored form to be finding the holes, the vertical asymptote, and to find the domain. And you're going to be using the simplified form for the holes and the x-intercept. So it's divided, as you can see, into those steps. I'm going to start with vertical asymptote. So let me make this bigger. Every time I'm asking for the vertical asymptote, remember, you look at your simplified form x minus 2 over x plus 3, and you try to look at the bottom of your simplified form, x plus 3. So then your vertical asymptote is going to be equal to negative 3. So x equals to negative 3. How did I get that? You set x plus 3 equal to 0. You move 3 to the other side, so x is going to be equal to negative 3. This is how you find it. Or you can just do the opposite. This is how you find the vertical asymptote. Now, how do I find the horizontal asymptote? Now, to find the horizontal asymptote, you have to always make sure that you look at your main equation, which is y equals x squared minus 4 over x squared plus 5x plus 6. Now, what you need to do is to look at the power on the top. The power on the top is a 2. And then look at the power on the bottom. The highest power on the bottom, it's 2. So as you can see, the top and the bottom have the same exponent, the same higher power. So what you need to do is you need to remember what we talked about. We need to look and think which clown will help you find the horizontal asymptote. So let's look at those clowns. Which clown will help me find my horizontal asymptote? Bobo means big on bottom. It means that the exponent on the bottom is higher. So if you look at this example, the higher power on the top is a 1, since x is to the power 1, and the higher power on the bottom is 2, since you have x squared. So big, the bigger exponent or the bigger power is on the bottom. So that's why B-O-B, Bobo, big on bottom. But this does not apply to the question that we have. Botno means big on top. If you look at this example, it means that the higher power on top is 2, the higher power on bottom is 1, so the bigger power is on top. Also, this does not apply to our example. If you look at Bosco, both, BO, stand for both, same. It means the exponent on the top and the exponent on the bottom, it's the same. So here it's 1, here it's 1, so as you can see it is the same. In this case, the horizontal asymptote is going to be equal to the coefficients. So the coefficient of 8x is 8. The coefficient of 4x is 4. So you look at the coefficient of those x's. You divide 8 divided by 4, you get a 2. So y equals 2 is your horizontal asymptote. Let's go back to our equation over here, our rational expression. Now, as you can see, the top is the higher power on top is 2, the higher power on bottom is 2. So we use Bosco. It means both the same. So you have to find the coefficients. So y is going to be the coefficient of x squared. So that's going to be a 1 over the coefficients of the bottom x squared, which is also a 1. So y is equal to 1 is going to be your horizontal asymptote. Now, to check your answer, it would be good to try to graph it. Every time you want to graph, remember, graph not the factored, not the simplified, you always graph the main equation. So you go to alpha, y equals to get the fraction, and then you put on top x squared minus 4. This is just to check if our asymptotes make sense. X squared plus 5x plus 6. Now, graph it and watch it as you're graphing. What's going to happen? First graph, second graph. Okay, so as you can see, there's going to be a horizontal asymptote over here, so y equals 1 makes sense. There's going to be a vertical asymptote over here, so x equals -3 makes sense. And now, as you were graphing, did you feel that the graph, the second part of it, skipped somewhere? So there's a gap over here in your function, and that's my whole. So we're going to talk about the whole next, the whole of your rational expression or rational equation. Now, to see if it makes sense, also go to second table. Now, let's see what happens if x is equal to -3. So let's go to -3. There you go. There's an error. So that's why an asymptote means your graph can never touch there. That's why this is going to be your error. And again, y equals 1 is going to be another one. As you can see, if you look through the table, there will never be y equals 1. So this is how you find your vertical asymptote. This is how you find your horizontal asymptote. Now let's talk about how to find the whole of a rational equation. Now let's go ahead and move on, and let's talk about how to find the whole of your function. And as you can see, the whole is whenever you were graphing, it skipped somewhere. So think of a whole as a point, or maybe just a hole in your function where your graph is going to skip. So if the whole is a point, then it will have coordinates x and y. Now, remember when you were factoring, you had to simplify. Now this one that you canceled out from top and bottom, this is going to be where your whole is. So x plus 2 is going to be where your whole is. So set it equal to 0, so x is equal to -2. So x is equal to -2 is going to be the x of your point, or the x of your whole. Again, you look at the one that you canceled out. Now to find the y of this whole, remember to plug it in. Where? In the simplified one. Not in the main, not in the factored, in the simplified one. So I got x is equal to -2. I need to plug it in x minus 2 over x plus 3, which is this one, the simplified one. So instead of x, I'm going to put -2 minus 2 over, and instead of x, I'm going to put again -2 and then plus 3. So as you can see, what I did is that I plugged in -2 whatever x is. So -2 minus 2 would be a -4 over -2 plus 3, which is a 1. So then the y of your whole is -4. So your point or your whole is going to be -2, -4. Now let's see if it makes sense. Now we're going to be talking about how to graph it later on, but now let's move on to something else. Now this is how you find the vertical asymptote and the horizontal asymptote and the whole. Now let's see, what else do we need to figure out? The x-intercept and the y-intercept. Remember that y-intercept means that x is equal to 0. It means when you look at your equation over here, it means that everything that's going to be an x is going to go away. So what's going to be left? So this is going to go away, go away, go away. The only thing that will be left is negative 4 over 6, which is equal to negative 2 over 2/3. So 0, negative 2/3 is going to be your y-intercept. So again, this will go away. Everything there that's an x will go away. So let me erase so we can use this equation again. To check your answer, you can go to turn it on, second table, and look when x is equal to 0, you'll see that it's negative 2/3. And this is what you got. Now x-intercept, it means you look for the ones that where y is equal to 0. Now to get this one, it would be helpful to look at the simplified form, which is x minus 2 over the x plus 3. Now, if you want to find the x-intercept, you look at the 1, you look at the top of your simplified form. So x minus 2, you set it equal to 0, so x is equal to 2. So 2, 0 is going to be your x-intercept. Again, you can go over here and look for the ones where y equals to 0, and you can see that x is equal to and y equals 0, so that's going to be your x-intercept. Now, I forgot to show you the whole, which is negative 2, negative 4. Now, if you go to your calculator and try to go to negative 2, you'll see that that's an error, and that's why this is a whole in your function. So the whole and the asymptotes are where the table will show you an error and where the graph will never cross. Now, let's move on. We just found the asymptotes, the intercepts. Again, you can use the calculator to find your intercepts, and you can always use the calculator and the table to check if your asymptotes and your wholes are correct by looking at the table, and you'll see that there's an error over there. Now, how do you find your domain? Now, the domain is everything from negative infinity to infinity except the errors. So let's look. What are my errors? Let's write them over here in the empty box over here, and this will help me find my domain. Now, when x is equal to negative 3, that's going to be my vertical asymptote. Y equals to 1, that's going to be my horizontal asymptote. So those are a no-no. They cannot be in your domain and range. And the whole is going to be at negative 2, negative 4. So those are a place where the graph will never touch. So they should not be in your domain, should not be in your range. So to write the domain, it means you look at the x and the x of your whole, okay? The x of the whole of the expression. So it's going to go from negative infinity to, which one comes first? Negative 3 or negative 2? Which one is smaller? Negative 3, so you write it first. Union, then negative 3. What comes next? Negative 2. So you go in order from smaller to bigger. Union, negative 2 to infinity. So every time you have an asymptote and a whole, you will have 3 pieces of your domain. Again, always it would be helpful if you write them down on the side, the asymptotes and the wholes, and these are a no-no. Your function can never, your graph will never pass through those. The domain, you look at the asymptote, the x equals negative 3, the vertical asymptote, and you look at the x of the whole. Now for the range, you look at the y equals 1 and the y of the whole. Which one is smaller? Negative 4 and then the 1. So the range would be from negative infinity to negative 4, then negative 4 to 1, then from 1 to infinity. Again, as you can see, every time you have a whole or an end and asymptote, there will be 4 or 3 parts to your range. Now, I hope this was helpful. Go ahead, take your time, watch the video again. If you have any questions, again, we're going to do practice on Thursday and Friday to do the graphing part. If you have any questions, please go ahead and let me know. Try the second example and the third example on the back pages. So try to do this one and this one on your own. Remember, to find the horizontal asymptote, you look at your clowns. Bosco, Bobo, and Botno. We'll talk more about that in class. This is just an introduction. See you tomorrow.